So we're trying to find the values of f of negative 6 and f of 5. So I like that we're doing this problem after last week's free response problems, because what we did last week was accumulation. And we remember, hopefully, that the area under the curve is equal to an accumulation of something. So the area under your derivative curve here will accumulate the amount for the original. So if we want to find f of negative 6, f of negative 6 would be equal to that initial condition that they gave us, f of negative 2, plus the integral from negative 2 to negative 6 of f prime. Okay, f of negative 6 is equal to that starting point plus the integral from the starting point to where you want to end up of the derivative. Now, are the limits on our integration here in the order that they normally are? No, it's usually least to greatest, so we need to flip that over and put a negative in front of that integral. Okay, your your limits should always be least to greatest. If they are not least to greatest, you need to flip it over and put a negative in front. What that's doing is, because we always move left to right when we accumulate, if you move right to left, then your area is going to be the opposite of what it normally was. So if we look at the picture now, because we know f of negative 2 is 7, we need the value of the integral of the derivative. That's the area under the curve. So from negative 6 to negative 2, we're looking at this first triangle right here. So that's 1/2 times the base, which is 4, times the height, which is 2. So that is 7 minus 4. F of negative 6 is equal to 3. And if we think about it to check, if at negative 6, our initial value is 3, we think about adding this area. It is a positive area, so it makes sense that by the time we get to negative 2, our y value is greater than that initial one that we have. Similar process for f of 5, except we don't have to flip it over. F of 5 is equal to f of negative 2 plus the integral from negative 2 to 5. That's in the order that we expect it to be. Least to greatest, so we don't have to flip it over and we don't need a negative. However, when we are calculating the area from negative 2 to positive 5, which is the end point, so we're going to do that entire semicircle and that entire triangle there on the right side. Just remember that the semicircle is below the x-axis, so it has a negative area. So I'm going to go ahead and put a negative in front of it. Pi r, well, 1/2 pi, so pi over 2, since it's a half of a circle. Okay, pi r squared is the area of the circle, so we need half of that. So pi over 2 times the radius squared. The radius of our circle here would be 2. So that's the area of the circle plus the area of that triangle. So 1/2 times that base is 3, and that height is 2. So the 1/2 and the 2 cancel. 7 plus 3 is 10. So we've got 10 minus 2 squared is 4. Divided by 2 is 2. So 10 minus 2 pi is f of 5. And I know that I just boxed in those answers. I told you not to box in the answers, but I have a lot crammed into that little tiny space. I just wanted it to stand out. So the rubric says you get 1 point for using the initial condition, 1 point for f of negative 6, and 1 point for f of negative 5. So that's a 3-point part. Yes, ma'am. Okay. The integral of the derivative gives you the accumulation of the original function. Okay, the integral of the derivative, they cancel, so it gives you the accumulation of your original function. Okay, part B. Usually they do some sort of graph analysis with these questions as well. Part B says, on what intervals is f increasing? So before you look at the graph, I always identify to myself, and this is the first thing that I write down, I would write down f is increasing when what? F prime is positive, which occurs, where does it occur in this case? -6 to -2 and 2 to 5, which occurs -6 to -2 and 2 to 5. Two points for your answer with justification. So you have to have both those intervals correct, and you have to have your justification correct to get that. Okay. I always just use parentheses on these problems because usually, like at the end point, that's where our function starts. So technically, it's not increasing or decreasing where it starts. At -2, it changes. So where it changes, it's neither increasing nor decreasing. So just always go with parentheses with those. All right, part C, find the absolute minimum value of f on the closed interval from -6 to -5. So first of all, I need to identify candidates for where we will have a minimum. So f has a, I'm going to say local minimum. Where does our function have a minimum? What change? From negative to positive, where f prime changes from negative to positive. So at +2, f has a local minimum where f prime changes from negative to positive. Don't abbreviate. From negative to positive, which occurs at x equals 2. But the key word here is it says absolute minimum. So anytime it says absolute, we need to not only check our local, but we need to check that versus our endpoints. So we can make a chart here. We can do x and f of x. So we need to check the endpoint, -6, which we know we already found that one. F of -6 was 3. We found that in part A. We don't need to worry about -2 because that would be a local maximum. So +2, we need to find that value, and then 5. F of 5 we found as well, right? We did, that was 10 minus 2 pi. We need to find f of 2. Well, it shouldn't be too hard because we already have the pieces, right? F of -2 is 7. And then if we find the area between -2 and +2, it's just the semicircle, which we already found had an area of -2 pi. So we've got 7 minus 2 pi is the value at 2. Okay, so we already knew that f of -2 was 7, right? F of -2 is 7. So from -2 to +2 is just the semicircle. We already found the area of the semicircle in part A. It was 2 pi. Because we started at x equals -2, and we end up at +2. That's the other side of the circle. So the area under the curve gives you your accumulation from -2 to +2. It's just like what we were doing in part A. I'm just finding it for another x value. Okay, so if we compare, and I know we don't have a calculator, but let's just use some number sense right here. Pi, you know, is about 3.14. So 7 minus 2 times 3.14, is that going to be greater than or less than 3? Less than. It's less than 3. And then 10 minus 2 pi, is that going to be less than the 7 minus 2 pi? No. So this is your absolute minimum value. So it says find the absolute minimum value. Okay. So the absolute minimum value occurs at x equals 2 and is 7 minus 2 pi. Okay, if it's asking for the value is always the y value. But you might as well throw in the detail of where it actually occurs. Okay. So that's 2 points. They give you 1 point for considering that it should or that it could possibly occur at positive 2, and then you get 1 point for your answer with justification. Pretty sure the table there is your justification, checking the endpoints and your local minimum candidate. All right, part D, for each of f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. So we're taking the derivative of what we're looking at. So that would be the slope. So what's the slope of our function at -5? Well, it's easiest to look at the endpoints here. So rise over run. So 2 units and over 4 units. So that has a slope of -1/2. So df double prime of -5 is -1/2. F double prime of 3. Let's look at 3. What's going on at 3? A sharp point. Okay, so f double prime of 3 does not exist. Because there is a sharp point. Now, on the rubric, it gives 1 point for f double prime of -5, which is -1/2, and 1 point for that it does not exist with an explanation. Now, their explanation, they don't use the terminology sharp point. They look at the slope from the left side and the slope from the right side, and the fact that they are not equal to one another as their justification, but I'm pretty sure that sharp point is a valid explanation for why it doesn't exist. Sharp points and vertical tangent lines, which this graph does not have. Well, like if they had asked us for the second derivative at -2 or +2, it would be the same explanation. I know it's not a sharp point as what's happening at +3, but it's a similar thing. Your slopes are drastically different coming in, and from the right side here, that really is a vertical tangent line. From the left side at 2, that's a vertical tangent line. So those are going to be 2 other places where the second derivative would not exist for this function. Okay, let's look at number 2 as well. I've got a little bit more going on with this graph, a few more peaks and valleys. But between -4 and +12, g is defined as the integral from 2 to the x value of f of t, which we are looking at f. So g is defined as the integral from 2 to the x value of f. So that's another way of saying that g prime is equal to f. The derivative of g is equal to f, because if I took the derivative of both sides of this equation right here, the derivative of g, the derivative of the integral, is the original. So what we're looking at is the derivative of g. Okay, you might want to, I would suggest writing that, because it can get a little, it just gets a little confusing sometimes when they use the two different letters, but that's what it boils down to. Okay, so part A is now a lot easier. Does G have a relative minimum, a relative maximum, or neither at x equals 10? So if we're trying to figure out relative minimum, relative maximums, etc., we're looking at a sign change on the derivative. We're looking at the derivative. So is there a sign change at x equals 10? No. Now, it does, I mean, it has a point there, and that's what most people are going to see. They're going to say, oh, well, that's a maximum, but we're not looking at the graph of g. We're looking at the derivative. There has to be a sign change to have a maximum or a minimum. So it has neither. Because f equals g prime and does not change signs at x equals 10. So 1 point for that. Part B, does the graph of G have a point of inflection at x equals 4? So if we want to know, does the original have a point of inflection, but we're looking at the derivative, what characteristic are we looking for on the derivative? Maximums or minimums. So do we have a maximum or a minimum at 4? Yes. Okay, so yes, G has a point of inflection at x equals 4 because f, which equals g prime, has a maximum at x equals 4. You get 1 point for the answer with justification there. All right, part C, find the absolute minimum value and the absolute maximum value of G on the interval from -4 to 12. Justify your answers. So let's see here. Let's identify our candidates. -2 and 6 and our endpoints, right? -2, 6 and our endpoints, because those are the only places where we have sign changes. But we also need to check our endpoints. So I'm just going to jump straight to a table since they asked for the minimum and the maximum. Sorry, that should be a G. So my endpoint, -4, a possible point, -2, possible point 6, excuse me, and the other endpoint of 12. So at -4, let's see here. We need to show some work over here on the side because g of -4 is equal to, look at how g is defined. It's the integral from 2 to the x value of f of t dt. Well, is that the order it's supposed to be in? No, so we got to flip it over and put a negative in front. The integral from -2 to 4 of f of t dt. So let's look between -4 and +2. We start with, I'm just going to put a negative in front of the whole thing because part of this was already negative. and part of it's positive. So between -4 and -2, we have a triangle that is below the axis. So I'm going to do -1/2 times the base is 2 times the height there is 4 plus, let's see, I'm going all the way to +2. So I've got 1/2 times my base there is 4. My height is 4. So let's see here. We've got -4 plus 8. So that's +4, but there's a negative in front of it. So g of -4 is -4. All right, g of -2, the integral from 2 to -2. We're going to flip this one over as well. We just found the area between -2 and +2. That was the 8 right there. And it just needs a negative in front of it. So f of -2 is -8. G of 6, the integral from 2 to 6 of f of t dt. From 2 to 6, let's see here, we've got another triangle. That is, the base is 4, the height is 4, so that's a +8. No negative in front of this one because we're good going from +2 to +6. And then finally g of 12. So from 2 to 12. Well, we just did 2 to 6. 2 to 6 was 8. Plus from 6 to 10, we're under. So that's a -1/2 times a base of 4 times a height of 4 plus another -1/2 times the base of 2, the height of 4. We have two separate triangles down there. So we've got 8 minus 8 minus 4. So -4. So let's see here, absolute min, absolute max. The absolute, and you need to write it in words, the absolute minimum value is g of -2 equals -8. The absolute maximum is g of 6 equals +8. So that's a big one. That one's 4 points right there. 1 point for considering your -2 and 6, and 1 point for considering the endpoints, -4 and 12, and then 2 points for the answers with justification. So I would assume 1 point for the minimum, 1 point for the maximum. And the justification is, of course, your table there. All right, last part, part D. Between -4 and 12, find all intervals for which g of x is less than 0. So we know our starting point. Excuse me. We know that at the very beginning, at -4, the value is -4. And since we had a minimum there at -2, -8. What? Okay. I'm having to think through this one there. Okay. So we've got at -4 is our starting point. At -2, our y value is -8. At +2, did we ever figure out +2? No, we never calculated +2. Well, be careful with this one because it wants to know if g of x is less than 0. So g of x itself has negative value. Okay, g of x itself has a negative value. It's not asking it's not asking where it's decreasing. That would be if f of x were less than 0. Since f is its derivative, that would be saying where g is decreasing. This is actually asking where is the function negative. Excuse me. Where is the function negative? So let's see here. I'm going to write down some work here. G of -4 equals -4. G of -2 equals -8. So we know that we are negative between those 2 points because we just identified that g of -2 equals -8 was a minimum. So we know that we're negative up to that point. So we got to figure out, okay, so where do we go from being negative to becoming positive? So if we add the next triangle, let's find g of +2. G of +2, at -2 we're at -8. The area of that triangle is 8. So g of 2 equals 0. So we are negative is less than or equal to 0 for -4 to +2. Because we were negative, we started adding, we got to 0. So from +2, we're going to add more positive area. We already have g of 6. G of 6 is 8. So we have to now subtract g of 10. If we find the area between 6 and 10, that would give us a -8, so that puts us back at 0. And then we know g of 12 is -4, so it's also negative between 10 and 12. Okay, so that one's kind of weird. I just used what we had previously figured out in part C, but you still had to fill in some pieces because we just found the absolute minimum and the absolute maximum, but it wants to know where is it actually negative on this entire interval. So that one, 2 points for your intervals, 1 for each interval. And then at the very beginning of the rubric, it says that as long as somewhere in A, B, C, or D, you identify that G prime is equal to F, you get a point for that. So we did that right at the beginning. So you get a point just for making that connection, that G prime is equal to F.